Assalamu alaikum sir, welcome to our presentation. We are from group 5 and our section is C. Our presentation topic is power plant design with AutoCAD electrical single line diagram of a 1320 megawatt power plant. Here is our group member. This is Afiat Jahan Mahi along with me, MD Taufikur Rahman, Ayun Akhtar, Iftikhar Hassan Email and Ifaz Hussain. Single line diagram distribution of power. This slide shows the distribution of power through the single line diagram. The single line diagram represents how electrical power is distributed from the power generation source to the various loads and distribution centers. We used AutoCAD Electrical to design this model for a 1320 megawatt power plant. Single line diagram of 1320 megawatt power plant. Here we present the complete single line diagram of a 1320 megawatt thermal power plant. It includes main transformer, switchgear, busbar and transmission lines. The diagram also includes protective device and control elements essential for safe and efficient operation. Layout design principles. Proper lighting and visual comfort, avoiding flash and shadows. Easy maintenance, directional lighting, emergency lighting setup.
So let me begin with the PMBC role. So it stands for Bangladesh National Building Code. This code is a standardized guideline that governs how building services, including electrical systems, it must be designed and implemented in Bangladesh. When we design any electrical system, especially in large infrastructure like power plants, it's crucial to follow the BMBC to ensure safety, reliability, and legal compliance mainly. It covers everything from wiring method and load calculations to protection system uh, and grounding and spacing requirements. Following BMBC not only ensures system performance but also minimize the risks of electrical hazards like short circuit, fires, overload, etc. Our project strictly follows these rules to maintain professional standards. So here we can see some point mainly minimum illumination level section. It's maintained mainly 10,000 lux for task specific lighting for individual zones using high lux video by values consistently across the area. And number two is utilization factor and maintenance factor. It uses realistic UF and MF values. Then number three is luminaries placement and spacing section. Mounting height and spacing must be ensure uniform coverage. Avoid shadows and beam overlaps to reduce inefficiency. And number four is emergency and escape. So it's provide emergency lighting or exist staircases and escape paths. This should work automatically during power failure, ensuring 10 to 50 lux on the floor. And finally, number five is wiring and electrical safety that follows standards for circuit load, protection device, and grounding and conduits. Fixtures should be easily accessible for maintenance or replacement. So in this slide, we see the electrical legend matrix. This is basically the key to understanding any AutoCAD electrical drawing, just like a map has symbols, and our electrical drawings use standard symbols to represent different components. For example, we have unique symbol for light fixtures. Here we can see, then switches, sockets, fans, circuit breaker, and distribution boards as well. Using standardized legends ensures that the design is universally understandable, not just by us, but also by engineers, constructors, and site technicians as well. These symbols follow international and BNBC standards, which improves coordinations and reduce confusion during construction or maintenance as well. In this slide, we also discuss the electrical legend also. This is the rest of part of the slide. This slide shows a more detailed version of the electrical legend, as we can see, where we can visually identify the symbols used in AutoCAD drawings mainly. Each symbols represent a real world electrical component. For example, we have specific shapes for a single pole switches. Here we can see ceiling fans, plugs, and fluorescent tube light. These visual icons are directly used in our layouts. Understanding and correctly using these symbols is a fundamental skill in electrical design, especially when working with software like AutoCAD Electrical. It brings clarity, saves times, and ensures everyone involved speaks the same technological language as well. In this slide, finally, we can discuss the our AutoCAD Electrical OB assignment. So, hobby assignment stands for outcome-based education, which focuses on what students are able to do after completing the course. In this assignment, we are tasked with applying all our theoretical knowledge into a practical project, which is designing a power system using AutoCAD Electrical. We did it mainly. It included drawing the single line diagram, placing the correct symbols, and applying the NPC rules and creating a clear functional layout. This hands-on task allowed us to understand how real-world electrical design works, from planning to software application, all the way to standard compliance. And it was a valuable experience mainly and helped strengthen both our technical and practical skills. So my part is closed here. From the next slide, my next group member will continue.
Hello sir, Assalamu alaikum. My name is Ayn Akhtar and my serial is 18. Today we will be discussing about a crucial aspect of power plant design, focusing on the electrical load calculations and lighting consideration. As you can see on this slide, a fundamental step in designing any facility, including a power plant, is accurately determining a required illumination. We start by gathering essential data. For instance, in our scenario, we are looking at an RMG approximately 883.6 square meters. Our goal is to achieve a new required lux level of 10,000 lux. To achieve this, we consider factors like the selected light fixture, a 32-watt LED bulb with 3000 lumens output. We also account for the utilization factor, which is the efficiency of light usage, and the maintenance factor. In our calculation, these are 0.6 and 0.8 respectively. This next slide provides a great example by showing typical illuminance levels for various areas, here illustrated with hotel spaces. Corridors are less critical. Pathways might need lower levels like 70 lux for hotel corridors. This level highlights the importance of tailoring lighting design to the specific function and safety requirements of each area within our 1320 megawatt power plant. Finally, let's talk about the technology that makes efficient and effective lighting possible in modern power plants, LED lighting. This slide showcases the diverse types of LEDs available for both indoor and outdoor illumination. The use of modern LED technology like the 32-watt LED bulb we used in our calculation significantly contributes to the overall efficiency and sustainability of a 1320 megawatt power plant, reducing both energy consumption and maintenance needs. Thank you, sir.
Assalamualaikum, sir. Thank you, my teammate. Here is my slide. I will describe this slide. This slide is AutoCAD electrical single line diagram assembly. This assembly is a simplified symmetric schematic representation of an electrical power system used for designing and documenting electrical circuit. It shows the flow of power through component using single line instead of multiple wires, making it easier to understand complex system. There are some key properties of an SLD in AutoCAD electrical. First of all, symbols. Predefined electrical symbols, such as transformer, breakers, motors, etc. from AutoCAD electrical library. Second one, intelligent components. These components carry data, rating, manufacturer info for BOM generation. Third one is automatic wire numbering, assigns and manages wire tags automatically. Layer management. Fourth one is layer management. Organizes components wire and automation on separate layers. Number 5, real-time error checking. Detects missing connection or duplicate text. Number 6, report generation. Produce bill of materials BOM, terminal plans and other report. Number 7, cross-referencing. Links related component just such as breaker to its contact. Number 8, compatibility. The such as supports the IC and SI and other standards. Next one. These AutoCAD electricals are some benefits. First one, faster drafting with automated tools. Number 2, ensures consistency and reduce errors. Number 3, simplifies modification and updates. Um, there is our project simulation. This simulation, and this is the circuit diagram. Thank you, my friend. Thank you, sir. I'm requesting to my fellow teammates, Ifazushan, to continue his slide.
Assalamu alaikum, this is Ifaz Hussain. My ID is 2246741. This slide shows electrical schematic design in AutoCAD Electrical. This slide showcases a portion of ladder diagram created using AutoCAD Electrical. It includes index symbols, motor connections, and wire tagging. Example components are indexing motor, push button, and safety relays. Mention drawing configuration, ladder spacing with settings and referencing method. Highlight the use of vertical ladder layout and multi-wire spacing, which is 0.5 units. Screenshots of the AutoCAD drawing with drawing properties dialog box. This slide shows the relay logic and control system. This slide shows how relay logic is implemented to control motors safely. Includes safety relay, NONC contacts, maintains switches, and controls relay. Displays a hydraulic motor and indexing motor integrated with push button control logic. Impairs safety compliance in industrial control circuits. Visual zoomed in view of AutoCAD schematic focusing on the relay and motor control section. This slide shows the environmental benefits of LED lighting. Outline 8 key benefits of using LED bulbs in industrial settings. High efficiency, high energy efficiency, up to 80% savings, long lifespan, which is to 25,000 to 50,000, low carbon footprint, comparatively with smart system, complete with green certifications, which is AED Energy Star, focus on environmental sustainability and cost effectiveness. We organize text with key bullet points on LED sustainability. Conclusion: in terms of sustainability and environmental impact, LED technology stands out as a transformative solution in the illumination industry by this drastically reducing energy consumption, eliminating hazardous substance, and supporting recyclable designs. LED contribute to a cleaner and more resource-effective world. Their integration with smart control systems further enhance energy conservation efforts. Industrial global industries move toward general practice. The widespread adoption of LED lighting represent a vital step in reducing environmental degradation, minimizing carbon footprints, and promoting a more suitable future of generations to come. Thank you.